For number 1, we are trying to graph the function g of x equals 2 to the x minus 1. So to do this, we're going to start by completing our little table for the base function 2 to the x. So this is where we plug in negative 1, 0, and 1 in place of the x, which 2 to the negative 1 is 1/2, 2 to the 0 is 1, and 2 to the first power is 2. And then we're going to start by graphing that set of points. So we have negative 1, 1/2, 0, 1, and 1, 2. And we have something that looks like this for the graph of just 2 to the x. And then what that negative 1 in the exponent tells us to do, because it's in the exponent with the x, that affects our graph horizontally. And specifically because it's minus 1, that tells us to move to the right. So we're going to shift all of our original points to the right 1. So that moves this first point to 0, 1/2, the second one to 1, 1, and the third one to 2, 2. And then we connect those to get the graph of g of x. Number 2 is a compound interest problem where the $5,300, that's going to be the principal. The rate is the 4.5%, so 0.045 as a decimal. And we're told that it's compounded quarterly, so that means that n is equal to 4. And we're trying to find the value of the investment after 5 years, so that's going to be the t. So then we're going to take all of that information and plug it into our compound interest formula. A equals p times 1 plus r over n to the nt. So that's going to look like 5,300 times 1 plus 0.045 divided by 4 to the 4 times 5. And then to get that into my calculator, what that would look like is 5,300 parentheses 1 plus 0.045 divided by 4, close parentheses, exponent button, new parentheses, 4 times 5. So to the nearest cent, we get approximately $6,628.98. Now for number 3, we run into the words compounded continuously, which tells us that this is one where we want to use the formula containing the e as opposed to this original formula. So A equals P e to the RT, where the 5,200 is going to be the principal, R is the 5.7%, so 0.057 as a decimal, and the value of the investment after 9 years, so T is equal to 9. So plugging into our formula will look like 5,200 times e to the 0.057 times 9. And then what that would look like in my calculator is 5,200 second ln to get the e in the exponent, 0.057 times 9. So we get approximately $8,685.53.